Hello students, welcome to the class of Digital Electronics. And today we will be discussing the topic Boolean Algebra. So you might have studied Boolean Algebra in class 12 and you must be familiar with some of the techniques of how to reduce Boolean expressions, right? So that is the basic thing that we will be discussing today, and further we will move on to the K-maps or the Karnaugh maps. So for today, let's begin with Boolean algebra. First, I will be telling about the usage of this Boolean algebra. So this Boolean algebra is basically a switching function. You design different switching functions and it has very variety of uses, especially in cryptography, where you are using code, encoding things, or where you are setting, like in very simple terms, you can say that you are setting a password, which is very tough, or you can say that it has some rules to break that password. So that is the cryptography thing. And in you also use this Boolean algebra in machine learning or artificial intelligence, where you have certain decision making process. Okay, so the this is a algebra which is created by operating the binary system. So my binary system, we all know till now that the binary system, it consists of two variables. You can say two major thing is there in the binary system, that is the zeros and the ones. So the variables are assigned only these two values, zeros or ones, right? Now this person called George Boole, he was the first one who has proposed this term, that is the Boolean algebra. It is on his name, George Boole. So he was an English mathematician from England, and in 1854 he proposed the system of Boolean algebra. This is concerned with binary variables and logical operations. So it is concerned with binary variables and logical operations. This is the second point that you should keep in mind if for any introduction to the Boolean algebra. Now, this is a very fundamental thing in the development of digital electronics, because digital electronics, all the circuits that you have, so basically those are the analog circuits which are abstracted inside that. And finally, on the terminal end, you can say that you just have to deal with zeros and ones. And these zeros and ones and the operations of these zeros and ones are handled with three basic gates, right? And this is also finding application in set theory and statistics. So the range of applications for this Boolean algebra is huge. Set theory, then I just said cryptography in modern, you can say the science, you have this cryptography. Computer science, it is very widely used. Digital electronics, you have it in your syllabus, so you can understand that the importance of its usage. AI and machine learning also we use. Basically, what we do is we design switching functions based on the specific conditions that is given. Say you have, for a very small example, I'd say that we have to do two work. Switching on the fan on plus light on. So if you want these two conditions simultaneously to operate, then you have to connect these two conditions with a AND operator. So the room is fully habitable. You can say you can enter the room or you can stay in the room. If these both things are there, fan on and light on. So this process can be followed with a AND gate. So we will see several types of gate over here, but the basic three gates that you have to keep in mind is the AND, the OR operation, and the NOT operation. So this is called negation, NOT is called a negation, OR is called disjunction, means either of the two, if it is going on, then the whole system will go on. And AND is called conjunction. For the system to be on, if two systems, say system A and system B, they are connected with the AND operation, for the system to work properly, both of them should be on. So this is the basic three gates. I'll just give you the truth table for these. So since we will take only two variables here, A and B, so these two variables can have four different combinations, right? So the combinations can be 0, 0, 0, 1, 1, 0, and 1, 1. Now, if you AND it, these two variables, so AND has a symbol that is dot, A and B. That time, if what I said was the AND operation will allow the system to work only with both A and B on. So this one, all these are off, and only the last one will be 1. If you have this OR operation, in this case, you have A plus B. Again, if you take the combinations of two variables, then the combinations will result, the two variables will result in 4 different combinations. So 1, 0 and 1, 1. Now, in this case, it is going to be on with even 1, 1s. So all these will be on, only this one is off. Finally, we have the negation. This is the OR. For the OR operation, you use this one. This is OR. This one was our AND. And for the negation operation, you need to take only one variable, and the output is going to be the complement of that. If you take input as 0, output will be the complement, that is 1. If you take input 1, the output will be 0. So this is called the NOT or the complement or the negation operator. The Boolean expression, or you can say it, the full Boolean expression, it will consist of the variables, which we call the Boolean variables. These will have values only 0 or 1. And then it will constitute a big function. Okay, there are several laws of Boolean algebra that is important for simplifying the Boolean expression. So let us deal with the laws of Boolean algebra. Laws of Boolean algebra. First is the identity law. The first one is identity law, which says that if you are adding 0 with any variable p plus 0, then see, this plus was what? My OR operator. What did you studied over here in the OR operator? That whatever is the, even if one of them is 1, the output is going to be equal to 1. So here if you say that p is 0, 0 plus 0 will be 0. If you say p is 1, then 1 plus 0 will be 1. Okay, so whether you take the value of p as 0 or 1, the output is depending upon this p only, not upon the 0. So identity law says p plus 0 equals p. The second one is the idempotent law. So if you confuse the names and don't remember the exact names of the laws and along with their functions, then you can just use the basic things of AND and OR. That will also give you the correct answer. What I mean to say is that here, if you have been given two variables a plus 0, then if you don't remember it also, you can use the basics, that if a is 1 or if a is 0, whatever will be the value of a, the answer is going to be the same value, because here there is a OR operator. The next one is idempotent law. Idempotent law says p plus p equals p. Again, the same thing, idempotent. Here you will take 0, 1 or 1, 0. Because of this plus, it's going to be p. If you take both zeros in that case also, or if you take both ones in that case also, the value is going to be p itself. So p plus p is equal to p. Now, very popular law that we have studied in mathematics also, that is the commutative law. Commutative law says that p plus q is equal to q plus p. Right, this is same thing is happening with the Boolean algebra also. Then we have also seen associative law. Associative law with maths, right? So same thing here also. In the associative law, p plus q plus r. Means first you will add q plus r and the result you are adding with p. That is same as first adding p plus q and then adding the result with r. Now here one question arises, will p dot q equal to q dot p or not? P dot q equal to q dot p or not? So if you take this AND operator and see the operations over here, it's going to be the same, right? P dot q will also be same. P dot q, if I do 0 dot 0, or if I take here I take 0 or here I take 1, this is going to remain the same. So P dot q is also equal to q dot p. So commutative law is holding for both the OR and the AND operations. And this associative law will also be holding for both of them. Now, if I am taking two operations, that is one and then OR, that is called distributive. Okay, that is called the distributive law. If I take distributive law, here what we are doing is P plus Q dot R. So first you have this OR operator and then you have this AND. So you can just distribute this plus on P plus Q dot P plus R. This is your distributive law. So these things, associativity, commutative, and distributive was the same thing as that in the maths you have. And you must have also done these things in set theory, right? Now the inversion, if I take the complement of P and then again I take the complement, it becomes equal to P itself. Now this one, the next one is very, very important. This is called the De Morgan's law. This is the very important law in Boolean algebra. This De Morgan's law basically states that if you have P and you P plus Q whole complement, then complement the variables and change the AND or to AND. So see, if I see this as an outer operator, the inner P is not complement, Q is also not in the complement form, so we will take its complement form and plus will change to dot. So De Morgan's law states that plus is going to change it to dot and the variables are going to complement itself. So that is also called the complement law, but same things we have to keep in mind. Now, if I write P dot Q whole complement, in this case, what will it become? P complement plus Q complement. So these are the sets of the De Morgan's law. Now, one, we have the complement law mentioned explicitly, but it can be included in the Morgan's law itself. P plus P bar is equal to 1. So if you take this AND OR operator over here, if you have 0 and 1 adding, then both, what is, if P is 0, then the other P1, that is P bar, will be 1. So 0 plus 1 will be equal to 1. And if you have this P dot P bar, then what will happen? That time it is going to be 0. Fine. Okay, now one few more things. This is P plus 1. You can just handle these with the knowledge of OR and AND, but for mentioning this, we are writing it. So P plus 1 is equal to what? This is 0 plus 1. It's always going to be, irrespective of the value of P, the answer is going to be 1. And P dot 0, if I write, irrespective of the value of P, it is going to be 0. That means if you are adding with 1, any variable adding, ORing, the OR operation you are doing with 1, then the answer is going to be 1. And AND operation you are doing, if you are doing with 0, the answer is going to be 0. Now let's do some few reducing the Boolean expression. Some questions on reducing the Boolean expression. So first question over here is, simplify the Boolean function. Simplify the Boolean function. The function is given as a plus b into, inside the bracket you have a plus b into a plus b bar and then a bar plus c. So first you are going to, yes, you are firstly going to multiply it. That is the distributive law we are going to use and simplify. So let's start simplifying this one. First one will be a, right? A into a plus a b bar plus b a plus b into b bar. Okay, now this side we are going to multiply a bar plus c. So a into a, this is going to use which one? A into A, which is going to be A dot A means 0 into 0 or 1 into 1. 0 into 0 will be 0. 0 into 1 into 1 will be again 1. So it is going to be A itself, right? So whatever is the value of A, that is going to be the answer. So A dot A will be equal to A. Next one is AB bar plus BA. Now here you can see this is AB bar and this is BA. So we can take A common and we can write here B bar plus B, and this is B into B bar. So if you are taking one as 0, other one will be 1, and it is AND. So if one is, in case of AND, even if one variable is 0, that is going to become 0. Fine. Now this is A bar plus C. See, I'm not naming the laws over here. I'm doing it with simple or and the meaning of that. That is better to do because sometimes we tend to forget the name of the laws, right? So here you see now, this is B bar plus B. So B, if I take 1, B bar will be 0. Or if I take B as 0, then B bar will be 1. So in any case, you are adding 0 plus 1. The answer is going to be 1. So A plus A dot 1, A dot 1. And this side it is A bar plus C. So A plus A is going to be what? A plus A is going to be A, right? And then you have A bar plus C. If you take this 0 plus 1 or 1 plus 0, whatever is the value of A, that is going to be the answer. That is why I've written over here A. Now next point is A bar plus A into C. A bar is going to be 0 plus AC. This is 0 plus AC. So the answer is AC. This way you are going to simplify the Boolean expression. So let's go through this once more. First, what we did is we firstly simply multiplied it. And then from here you see, this is the first one, A dot A. Whether you take the value of A as 0 or 1, the answer is going to be A itself. That means any variable or and with itself is going to be the variable itself. Okay. Now here we had A common, so we took it outside and B plus B bar. We are doing the OR operation. If one is 0, other one is 1, answer is going to be 1. And if you are doing that the same thing, one variable as 0, other variable as 1, but you are ANDing it, that kind the answer is going to be 0. So this, see the difference over this one, B plus B bar and B dot B bar. B plus B bar is 1, but B dot B bar is 0. Then here it is A bar plus C. And finally, we had this as 1, so A dot 1 is A, and A plus A will again be A. Okay. Now here A bar plus C, A bar plus AC. Now A plus A, let us just see this part, 0 plus 0 or 1 plus 1. These are the two cases possible. So this is also giving you the answer 0 and this is also giving you the answer 1. Whatever you take the value of A, the answer is that value only. If I take it 0, then the answer is 0. If I take it 1, then the answer is 1. That is the reason I have written over here A. So even without remembering the names of the law, you can do it. Let's do another equation. So the next question for this is reduce the Boolean expression. A equals to, so the xy plus x into y plus z plus y into y plus z. So first thing you're going to do is multiply this xy plus xy plus xz plus y into y, right? Y into y will give you y only, but let us write it first and then yz. So this is the two same thing. A plus A, that is going to give you A only, or you can say xy plus xy will give you xy. Here xz, this will give you y itself, and this is yz. Now in these two, x is common, so I will be taking x outside, y plus z. In these two, y is common, so I will be taking y outside, 1 plus z. Now irrespective of the value of z, the answer is going to be 1 because which operation is between 1 and z? Here the operation between 1 and z is the OR operation. So the answer is going to be 1 only. So this is going to be x into y plus z plus y. Now again, if I write it xy plus xz plus y and I combine this one and this one, we get more simplified form. So that's why I rewrote it xy plus y plus xz. Fine. Now if I take y common, this is going to be x plus 1 and this is plus xz. Now this x plus 1 will give me what? 1. So y plus xz. This is the simplified expression. So this way we are going to simplify. We will be doing 2 more questions in the next class, and in the next class itself we will be starting K-map. Thank you everyone.